An intelligent P&ID process and instrumentation diagram is a combination of a CAD drawing and a database that is created and maintained concurrently. The intelligence comes from the real-time link between the entities shown on the drawing and specific data stored in the database. How traditional process and instrumentation diagrams are created. P&IDs are usually created under the supervision of a process engineer who is responsible for process flow, equipment identification and sizing, flow rates, control and related information. As a project progresses, it becomes necessary to tabulate, manipulate, sort, and/or organize nearly all information that might be present on a P&ID. Information pertaining to items such as motors, instruments, valves, piping, and interlocks is arranged into lists or reports for reasons ranging from purchasing to process control. Whether the project P&IDs are created with the intelligence feature or by conventional CAD methods, these lists and/or reports will no doubt be created. The fallout of the traditional system with conventional P&IDs, these lists are created manually by taking information off of the P&ID drawing and entering that information into a spreadsheet. This process creates a situation where data exists, by necessity, in two different locations. Invariably, things change. The responsibility of managing two sets of hopefully identical data becomes enormous. Here, Infotronicx Smart Plant P&ID and CMMS framework comes into picture. Let's see how. 4 advantages of Infotronicx Smart Plant P&IDs and CMMS framework. 1. Within the Infotronicx Smart Plant P&IDs and CMMS framework process and instrumentation diagram environment, data entries made to either the drawing or the database are managed in a single database and are kept current in both platforms. One advantage of the Infotronicx Smart Plant P&IDs and CMMS framework is that the various lists and reports described previously can be generated anytime after the drawings are started. For example, if the client needs a quick horsepower estimate, a motor report can be generated in a matter of minutes tabulating each motor and its corresponding rating. This data will always be consistent with the latest revisions made to either the database or to the drawing file. 2. Infotronicx Smart Plant P&IDs and CMMS framework contain more information than their traditional predecessors. For example, when a pump is inserted into a P&ID within the Infotronicx Smart Plant P&IDs and CMMS framework environment, the software requires inlet and discharge sizes to be input so that the background database can track the piping into and out of the pump. The same holds true for most inline equipment and devices such as valves, flow meters, etc. 3. Infotronicx Smart Plant P&IDs and CMMS framework also offer significant advantages to the processing facility long after the construction project for which they were created is complete. Since the data within the P&ID is maintained in an open database format, Microsoft SQL Server, the data is available to other applications for viewing or editing. Maintenance departments, for example, frequently incorporate database applications to organize their efforts. 4. A common problem in a processing facility is in knowing with certainty what size impeller currently exists in each centrifugal pump. It is unlikely that most facilities update each traditional P&ID when such change occurs. If a facility is equipped with use of Infotronicx Smart Plant P&IDs and CMMS framework, the maintenance personnel can, with a few keystrokes, update the data record for a particular pump, and the P&ID will be up to date at the next printing. Our Infotronicx Smart Plant P&IDs and CMMS framework process and instrumentation diagrams hold substantial benefits for plants of all sizes. Infotronicx is qualified to create smart P&IDs to make industrial processes more efficient. Let's see it in action.
On their behalf. Bentley offers a variety of technologies specifically addressing the requirements of companies owning and operating process plants. Today, this session is going to focus on how design tools contribute to safer and lower cost plants. First, let's have a look at what we mean by design tools. The plant design tool state-of-the-art has evolved a lot since the drafting days. Many of us remember that the days when a deliverable went on paper and then to the field and ultimately into a file drawer. In the early days, CAD was still pretty much the norm via a plot. This was still the case with via a plotter or printer to get the same piece of paper out. Models came along and helped us visualize the design, but ultimately they still primarily created a 2D drawing for construction and plant records. The CAD database hybrids, well, that extends the graphics CAD model with a relational database. That allowed us to do project-wise reporting and data sharing and the beginnings of tag management. Now, reality capture technology comes along, and laser scans and photogrammetry allow existing plants to start with a fully dimensional 3D model of the existing plant. Now, this technology can be applied to all sizes of new construction and rework alike across the entire life cycle. So why do we bother with all this? Didn't the 2D drawings do the job just fine? Do 3D models really impact the margin of a facility? Today we're going to look at current issues for plant owner-operators and how the design tools affect those. So, for example, records management is more critical than ever. At a minimum, accurate documents like P&IDs are a legal requirement. Owners also have to consider the impact to downtime during plant shutdowns when plant records are found to be incorrect or out of date. This adds to the scope of work and often the length of an outage. Regardless of commodity prices, which everybody knows has been an issue in the oil and gas industry and mining industries lately, plant owners have always cared about minimizing operating cost. When these factors are considered earlier in design, the savings are multiplied in construction operations and maintenance. So with so much at stake, it's no wonder that a lot of plant owners specify the tools and methods that are used when design work is performed on their behalf by in-house or contracted resources. Of course, modeling and drafting tools need to develop deliverables in the most productive way. This is going to lower the cost of engineering and design performed on a project. That also supports shortened schedules. Today, this productivity also requires that tools are able to allow collaboration between members of distant teams. Global work share, I think we call that. And in today's joint venture and design build scenarios, it's common for multiple contractors to contribute to a plant modification. In this way, a consistent set of design information contributes to the shortest schedule and the lowest cost. In such a situation, common material specs and reporting formats across all the contractors allow for material requirements to be procured at the lowest possible cost. And reporting on long lead items earlier in the design process, that shortens schedules and lowers material costs. That same material data captured to support procurement, that'll help in operations and maintenance if we're able to bring this information into our plant records, complete with part numbers and tied to storehouse and spares. Clash management and design reviews earlier in a project minimizes the field rework and involves operations and maintenance long before the designs are final. And the results are clear on this one. The technology saves engineering cost, construction and material cost, and shortens schedules. This lets owners begin plant production earlier. But maybe more important than these savings are the impact of good plant records on constructability and operations of the facility. Finding accurate information in a consistent format can be the difference between an appropriate operational change and a costly unplanned shutdown. So in order to control these factors that we're discussing today, plant owners are specifying more than just drafting and CAD standards. They're mandating specific formats for deliverables and even the tools used to create and edit them. They're required handover. So these are required handover of data, documents, models, and reports in the contract often. And we use these to populate inspection systems, put spares and materials in storehouses, and provide engineering records to operations and maintenance, and provide a training tool. If an owner is going to specify the format of a project deliverable and the technology used to produce it, what factors would they consider when selecting the right ones? Well, Bentley developed the plant solution with the total life cycle in mind, and today we're going to take a closer look at how the Bentley plant solution fits into this discussion overall. We'll start with P&IDs. When it comes to a P&ID, it's critical that the P&ID on record matches the existing plant configuration. Not the original as designed and not as proposed, but maybe not yet or never will be built scenarios that are represented in a P&ID document. So meanwhile, one or more copy of a P&ID can exist in some form of proposed state, in-house, or at a contractor site. The changes to this P&ID can be done well ahead of any plant physical change, and the owners need a way to visualize these changes that are proposed against the current set of P&IDs. Using OpenPlant P&ID, the changes are being tracked automatically and embedded into the document to be reviewed between any two versions. So in this example here, we see that the color-coded set of changes are captured between the new or deleted or changed portions of the P&ID. Similarly, we can see the differences between the asset tag database and the current P&ID drawing. So these can be individually reviewed and approved or rejected. An owner can leverage these features to ensure project P&ID changes can be identified between the record P&ID and a project P&ID. Delays to this process could impact startup and lead to misinformation in the plant records. So the tools used to maintain drawings of a physical layout and the makeup of the plant components, those should be able to support a similar change management scheme. Using a component-based design approach, Bentley's OpenPlant Model Server allows concurrent modeling of an equipment and piping, while the record set reflects the current plant configuration. Comparison tools allow for quickly integrating a project into the records as new equipment is commissioned. So there's a rumor that some plant owners still work exclusively in a 2D drafting world. And maybe the idea of 3D modeling seems like overkill or too complex for a small rework assignment. OpenPlant is a full 3D intelligent piping and equipment modeler, but it's also super easy to use. Users find it faster and easier and more accurate to design in 3D and extract reports, plans, sections, and isometrics. When we add in the new reality capture technology, we'll talk about those in a minute, then 3D is pretty much a must for all projects involving equipment and piping. So in this example, what we're going to do is give you an overview of just some of the features of 3D modeling using an intelligent 3D piping modeling tool. So notice when we so this is a spec-driven system. The right materials are selected. What we're doing right now is we're just routing piping. It's reading from the spec. We're writing in a isometric view. We can insert inline components. They're read from the spec. They cut the line. And of course, as we did with the nozzle, all of the fasteners and gaskets are placed automatically. Inline components can be dragged along the line. Dynamically placed and rotating of the hand wheel. By just picking and clicking here, we're actually building an intelligent model. After we route another little line here, we'll interactively edit the line because the reality of it is we'll need to massage the design after it's originally placed. Notice the appropriate flange is mated to the nozzle. It's reading the data off of the intelligent nozzle. Now that we've got the routing, what we can do is select different sections and just drag them to where we need them to go, keeping everything connected. There we go. So we're working in 3 dimensions, but we're pretty much just grabbing things and moving them where they need to go without a lot of manual fancy 3D manipulation. There's also a feature to apply a slope or reapply a slope. We could have routed it to slope, but this applies it after it's been routed. It can be edited using that dialog. While we're talking about changes, when we pick this line, we have the ability to reread the data for that from the pipe spec that was used to source it. So what we're going to do here is we're going to take a look at some of the quick replaces by rereading the pipe spec. As the process design might change, we also need the ability to go through there and maybe change the type of valve. That's a block valve. Maybe if we wanted to throttle that valve, we'd change it to a ball valve. So we're going to show how to do a more advanced replace and reselect that from other valve options available through the spec. And it's actually going to change the dimensional object and replace all of the flanges to the correct length. Notice we've got a different valve there. Now we'll just replace the top work. Similar editing allows us to grab the inline component, move it, have it connect all of the flanges and gaskets along that line. And we can always just drag and reorient that hand wheel just by picking it. So the advantages of 3D design can be accomplished without having a dedicated 3D specialist on a design team. It's pretty easy to learn how to use this stuff. That was the real point of it. There's other features we're not going to take time for today, but comparing the 3D components to those in a P&ID to ensure consistency, all of that stuff is supported by OpenPlan as well. So one of the other big advantages of 3D modeling of piping is the automatic creation of isometrics used for fabrication and assembly. In fact, owners are known to maintain the isometric as part of their plant records. So Bentley's isometric drawings are a little bit different in that they are intelligent and contain all of the design properties for fittings, piping, and nozzles, etc., that are used in the 3D model. Those are embedded into the isometric drawing as well. And this provides an ideal reference for inspectors and maintenance crews. So what we're talking about here, if you're an owner, how can one tool specify to accommodate all the sizes of a project, from shutdown-related retrofit work all the way up to the big grassroots capital projects? Some tools, they might be super easy to use and even make a nice-looking drawing, but sometimes that simplicity doesn't support the complexity of the largest plant projects, and it doesn't feature the depth of content to serve as a real plant record. Well, that tool's just too small. I'd call that more like a drafting tool. But some tools that offer the big project features for the largest projects, well, those are likely to come at the expense of being able to support the kind of projects performed most by an in-house design team, or the shutdown-related projects. Those tools are just too complex, and they'd probably be too expensive too. That tool's just too big. The right tool for the job needs to work in a field trailer with minimum training and occasionally no network connection at all. It also has to allow a connected user to collaborate with teams in other offices, other countries, or even other enterprises. That tool needs to scale the features with the size of the project using the same configuration and the same data and documents. That's the right tool for a job if an owner is going to specify it. So to make the work on all projects and for all sizes, it has to be easy to adopt. Bentley's design tools are accessible for all sizes of companies as well. It's easy to learn and use, and Bentley's Connect Advisor, which is a relatively new initiative, goes one step beyond training and extends experts right to your desktop. So with the Connect Advisor, you can get product training and information you need when it's needed without having to leave your design application or search for relevant content. It's learning interactively, and it's staffed by thousands of experts in captured content or even live interaction with a real person. So in the next slide, we'll take a look at how that works. So let's say a new user has a technical question. Oop, I've hit the button too soon. Sorry about that. So this is how it looks when you're running inside of OpenPlant Modeler. Let's say you have a technical question, maybe something that wasn't really brought up during an online training session. One option is to search the forums and wiki pages of the Bentley community site. Sometimes you need an immediate answer, and when the user's working connected, these resources are available right away. In this example, we see a question posed to one of the online advisors. He asks the question, a few follow-ups, and the answer is delivered. If the user needs a demonstration of how a particular feature works, this is provided during the same virtual meeting or using one of the many sort of captured mini training sessions that provide an example how to use a particular feature. And since it's context sensitive, the system knows which feature you're trying to use and presents you with options that are relevant for that particular feature. So this technology removes obstacles to standardizing on a design tool, and that too will ultimately lower the cost of project work. If it's easier to install, it's easier to specify, and fewer obstacles means a smoother, lower cost adoption. So now that the user is able to make models and drawings, what's the next step? So the power of engineering information is extended by making it available where it's needed, not just limited to the authoring tool to view a report. Bentley design tools are built on open published standards, and using Bentley iModel technology, information is shared between phases and across applications. This allows applications like OpenPlan to read from other formats, and in this way, legacy information developed using other tools can be imported into OpenPlan and edited as if it were native. In the next few slides, we'll take a look at iModels and the tools to create, analyze, and view them. So these are fundamental to how engineers, constructors, and owners can leverage lifecycle data created during. Since the iModel is the heart of how Bentley tools exchange information, what we're really going to look at here is what is an iModel and how does it work. We're going to coin the term information mobility and information mobility challenges. We need to have the ability to track a document and where our project information comes from. And we need to know who prepares it and when it was prepared. We need to be able to get information from multiple sources, and sadly these are often in varying formats. We need to ensure that the data we're getting is correct and secure. And oftentimes we rely on just the lowest common denominator, like a basic CAD file or a text file, to get information. And these are often exchanged just using emails or on a spreadsheet. And clearly that's not the best way. iModels aim to resolve that. So iModels are the currency for exchange for projects associated with the life cycle of plant assets. iModels contain information with precision and no loss of accuracy. They store what we call provenance, so they remember where they came from, what the original source, and the state of the information when it was published and why it was published. They're also self-describing. You don't have to know the original application. You don't have to have the original application or even know what it was to display the geometry or view the business properties in a set of components in a file. Every iModel carries with it the schema that describes its content and context. And they're flexible. They can be transformed to conform to any industry standard or to contain business data aggregated from other sources outside of the design environment. And they're portable, so they're optimized for sharing and distribution with a variety of tools provided at no licensable object. It's iWare, as we call it, is available freely to all through the Bentley website. And finally, iModels support digital rights management and digital signatures to ensure they're secure and reliable. An iModel is basically a file that contains graphics, data, and relationships, and they're published directly from all the Bentley design tools. There's over 70 Bentley products like EchoSim, OpenPlant, etc. that will directly publish an iModel. But that's one at a time. Automatic publishing servers allow iModels to be produced automatically using the ICS server. We're not going to drill into that too much. But what about non-Bentley applications? We also support a variety of connectors that allow iModels to be created for a variety of other design tools. So iModels produced from various design phases look a lot like drawings. Bentley developed the iModel transformer as a way to adapt this information for downstream requirements. With the iModel transformer, you can tailor information produced by applications to filter out data that's not required, or to add information from sources like spreadsheets, schedules, or maybe even other iModels. This allows us to combine information generated by different applications and work with it in a uniform way. So mapping information allows us to take an iModel and have it conform to a different schema or to conform to another standard. We can integrate information created by different applications to support decisions or provide some other uses like relate data that's already in an iModel together. We can also use this for, say, inventory or reporting to develop estimates or to support purchasing. to manage tagged items or to quantify bulk materials needed for construction or for shutdown planning, this sort of thing. So another example of how iModels support the owner's requirements is data validation. Validating an iModel against a set of standards is critical if an iModel is to be used as a handover between lifecycle phases. The ICS validation process can start from either the desktop via the iModel Validation Explorer or through an automated input from an application like ProjectWise Explorer. Any application can call the ICS validation, and the input for the process just includes an iModel, obviously, the name of the standard, which is basically a set of rules to be applied to the iModel, and a target database where we're going to focus the results of the validation. So the iModel Explorer is a desktop client that's used to validate configurations including rules and rule sets. It provides visibility to a visual review of the iModel along with its results for content, warnings, and errors. And these are basically driven by a rules library. Rules libraries can be developed either right in our schema, which is a set of Bentley tools, or just using Python scripts, which users can develop using our API. So we've shown that iModel transformation services provide the ability to aggregate, relate, filter, relate, and reformat the content of an iModel based on whatever configuration rules are needed by an organization. We can also provide ways to export information out of any iModel for use in downstream activities. So you can directly access the data that's in an iModel using an ODBC driver. That'll allow it to support applications like Excel or Access or Visual Studio or Crystal Reports or any ODBC compliant way that you need to summarize data. And finally, if there's no out-of-the-box way to do it and you need to access the data that's contained in an iModel, Bentley publishes a software development kit which will give you the ability to produce or consume iModels programmatically from whatever third-party application needs to access the information that are contained within. So how do we view the graphics of the iModel? Right now, that's Bentley's Navigator application. It's worth noting that the navigation is available on mobile platforms like iOS and Android, and certainly all the Windows platform. Soon to be available from Bentley is a web-based viewing tool for iModels as well, and those usually provide the same interface across all platforms and give us the ability to comment or mark up the iModel as well. So this is basically how OpenPlant models and the information they contain are available to other Bentley applications. So we use iModels for analysis, visualization, and reporting. And iModels are how Bentley applications share information between all applications and across the enterprise and between all lifecycle phases. It's one of the ways that an owner can extend the value of the design data. As a plant owner, most of the project work involves some existing equipment. Bentley's plant design solution accommodates field rework in a few ways. Using reality capture technology, we can now minimize survey work with point clouds or photos. The resulting 3D models are dimensionally accurate and reflect the current plant component. For this, we can produce field drawings such as dimensionally accurate demolition drawings or final arrangement drawings. As we already discussed, P&ID change management allows us to work on a copy of a P&ID and visualize changes required to the original. Bentley technology also allows proposed plant revisions to be visualized along with photorealistic 3D scans of the existing plant. Reality capture technologies provide a way for existing plants to benefit from the 3D intelligent design tools without the monster manual task of building a model of the existing plant. This includes the ability for OpenPlant Modeler to interact with laser scans during a modeling session. Context capture uses digital photographs to produce a scaled model of a plant. And LumenRT, which is an animation software, uses a hybrid of the existing and proposed plant components to allow owners to review a simulation of the full design in full context. Up to 30% of the design cost of a typical brownfield project, that's spent on executing and processing site surveys and laser scans to address all the out-of-date or missing plant records. At the project's end, drawings become out of date as equipment changes occur during operations and maintenance, forcing each project to repeat the cost of establishing an accurate as-built reference. Bentley's plant design solution breaks this cycle. The solution enables the construction of a data-rich, intelligent asset model that's a single current source of information for your facility. Field staff access the model and provide markups that engineering uses to maintain an accurate as-built record. This serves as brownfield this is going to save brownfield projects time and money. Bentley's solution includes software applications to create an accurate 3D model of your existing plant using laser scan data and simple digital photography. Additional applications complete the asset model with automatic production of 2D drawings and linking to equipment specs and other engineering data. So context capture lets us take pictures with just a regular digital camera to create a 3D mesh out of pictures. So we can take a drone to fly around the area and then create some ground-based photos. This will create a 3D mesh, and everything is merged together to show how the new project equipment will look like in the existing plant. This allows for better space management and prevents costly clashes during construction. Here's an example of modeling a plant with context capture. Here it is. This 3D model was created using only photographs taken at various angles using drone-mounted and handheld cameras. Notice that rather than a point cloud with millions of unrelated points, this model is a mesh complete with textures captured by the camera image. This reality mesh can be used as the background for a set of proposed plant changes or used in conjunction with point clouds referenced into any of Bentley's PC-based CAD modeling and applications during the layout and design phases. The mesh can be reviewed using Bentley Navigator, which is available, as we already said, on, on all platforms, to allow construction operations and maintenance teams to review the proposed new equipment in full context. Design reviews can now happen earlier in the design and can be available to all and not just the folks familiar with reading 2D CAD drawings. This allows designs to be optimized for savings to the total cost of ownership. On the previous slide, we reviewed a static 3D mesh of an existing plant. Using LumenRT, we can animate reality mesh point clouds and PC CAD models to animate and visualize the new plant. With LumenRT, you can immerse plants within a real-time visualization environment to help you tell a better story by allowing stakeholders to experience the design in full photorealistic 3D with various lighting and seasonal settings. And not only does this provide a powerful visualization tool, but with virtual reality devices, this intelligent 3D plant model is available for construction simulation or operator training as well. Here's a quick overview of how we can apply textures, and you can change the seasons so the leaves on the trees change, and you can add people and items to your model to create a real interactive environment that this can be shared with all your business and community stakeholders as well. So the idea is this takes us into the proposed plant with a combination of what's there already and what's proposed. So today we looked at a way that an owner can lower some cost and increase margins by leveraging the technology used to design plant equipment. We looked at how Bentley tools specifically address the needs of the plant owner.